Okay, it is Tuesday, March the 2nd. What we're going to do is I'm going to answer any questions in class that you have about any of the slides. I did add the answer key to Google Classroom so you can kind of check it. We'll do the cool down. If you get any incorrect in the cool down, it's going to send you to a video, and then you'll get the correct answer and it'll show you how, and so that'll walk you through that. So today we have a warm up. We'll do some slides together. We're going to continue to combine like terms, and then we'll have some independent practice. Your spiral review is due Thursday if you have time. And then also, hopefully by the end of class, you'll have that coordinate plane review task turned in. Okay. All right, so if you haven't done the warm up, there's actually 2 slides to it. I don't know, all my graphics aren't showing up here. Here they come. Okay, so pause and do the 2 warm-up slides and then come back. Okay, if you did do your warm-up, so this one was kind of a drag and drop like terms, just a quick reminder. So here we have a tree full of y's, so we would put all the y's here. We cannot combine x and x squared. They have to have the same exponent. So this is a tree of x squared. Looks like just numbers here, constants. And here we have z's. So your completed trees should look like this, any order. So the x, y, and just the x and the y cubed didn't have a tree. We can't combine them with anything else. So they did not have a place. For the next one, you needed to find out who was correct and incorrect, and then tell why. And Anna actually combined her terms correctly. She combined her x's and her y's, and her final answer was 10x plus 8y. Jacob was incorrect because he went ahead and then after he combined them, then he combined the x's and y's, and they're different terms, so we just can't combine them. We need to leave them like Anna did. Okay, so we're going to review combining like terms today, and we're going to just apply it to perimeter. Okay, so here is a chart. We identify all of our like terms. So here I've got x and x. Remember, we want to take the sign in front of it because that's what's going to tell us what to do if we're going to add or subtract. And if there's no number in front of the letter, it does. Every variable has a copilot, coefficient. And if we don't see it, it's 1. Okay, so this would be like 3x minus 1x. And if we think about the dog breeds, 3 Cholos, and then 1 goes for a walk. And then we have how many left? 2 Cholos. Then we can put our constants together and again take the sign before. So, and you can think of integers at this time. So -7 or -7. Think about if you start at -7 and then you add 2. So you're missing 7 and then you find 2. Well, you're still missing 5. Okay, so if you want to use a number line to kind of do that. So we have 2x, and then we had the 4y, and we don't have anything to combine it with, so we just bring that down. Okay? And you don't have that slide. It was just a quick review. So what we're going to do today is what we did yesterday, except we're going to use it on polygons, finding the perimeter of polygons. So you may see, if you look at slide 11, you may see some variables, some expressions showing the sides of polygons. we don't necessarily know what x is, and that's not the point. But what we want to do is write an expression for the perimeter. Perimeter is adding all of our sides. So what we would do is take all of these expressions and add them together. So it would be x plus 9 plus x plus 9 plus x minus 4, okay? Which would look something like this. And we just don't want that long expression. So we want to simplify it. We want to make it shorter. And that's when we combine our like terms. So, and you can think of dog breeds if you want. I've got my Cholos, my X's. They can be grouped together. So I've got one here. And I'm taking, if there's no sign in front, it means positive. And I'm taking the sign here and here. And if there's no number, it means 1. So I've got 3 Cholos. And then I can put my constants together. I've got plus 9. They can be our humans. Plus 9. It's 18. And then 4 go on break. Minus 4. And that would be 14. So I've got my 3 X's. And when I put these 3 numbers together, that gives me positive 14. And I keep going until my terms are different. They are all different. I cannot put them together, and that's it. We don't know what x is. It doesn't matter. It may tell us, but right now we just simplify the expression. So 3x plus 14. Okay. So number 12, look at the next slide. So this is a square because all these are congruent. And they're all y, whatever y is. So we just want to write an expression for the perimeter. So we would have y plus y plus y plus y. But we can definitely combine those to make it shorter. They each mean 1. And we'd have 4y. And a number next to a variable means to multiply. That's the coefficient and the variable, multiplicative. Oh, okay, so number 13. This shouldn't have come down there yet, but okay, so we have a rectangle and we want to find the perimeter. You just need to remember that they might not give you all the sides, but you do have to add all the sides for perimeter. So if this side is 2w plus 3, this side over here is 2w plus 3. If this is 4w plus 8, this is 4w plus 8. So I want to remember to add all of that. So if I wrote it all out, I would have this long expression right here, 4w plus 8 plus 2w plus 3 plus 4w plus 8 plus 2w plus 3. And then I'm going to look for like terms. So I want to make it a little bit shorter. So this has 1, 2, 3, 4, 5, 6, 7, 8 terms. Okay. So I kind of started here, but I'm going to put my W's together. You think of Weimaraners. The Weimaraners go together. There's 4 plus 4 plus 2 plus 2. And if we put them all together, you get 12 Weimaraners. Okay, and then you're going to look at your constants. And you can put your constants together. And if they all have an addition sign, they're all positive, you're just going to add them together. 8, 3, 8, and 3, which will give us 22. So we can't put our Weimaraners with their humans here, so that's separate. That's all we can do, 12w plus 22. We don't know what w is, and that's okay. Okay, we're going to do 2 more, and this time we're going to actually figure out what they're going to give us what the variable is, so we can actually have a number. Here's the triangle. We're going to find the perimeter. This side is a, this side is a plus 3, this side is 2a minus 5. So first, let's get an expression. So it's a plus 3 plus 2a minus 5. So you may not have to write it all out. Maybe you can just, here's 1a. Think of an Akita. That's a dog breed with A. So 1 Akita, 2 Akitas, and then 2 more. If there's no sign, I'm going to add. So there's 4 Akitas, and then I've got 3 humans, and then -5. You want to take the sign. So you can think of it as 3 minus 5, or you can start with -5, or -5 plus 3. But when you combine those two integers, you get -2, okay, or -2, whatever, however you want to say it. So we have 4a minus 2. I could have done 4a plus a -2, but then I would have to put parentheses to kind of separate it. So we'll just put it this way. So there is my perimeter. Now, you see extension. So they're going to tell us what, well, actually, we don't even have a z. We don't need that part of it, but they're going to tell us what a will be right now. So let's say a is 3 millimeters. Now, can we substitute it into the expression 3 for a, and then actually get a number. So a is going to be 3. Forget about that z. I didn't need that. So 4a minus 2, I'm going to substitute 3. That's multiplicative. Again, just I do my multiplication first. 4 times 3 is 12. Then I subtract. And so now I can actually have an answer. So for this one, and this is an extension. If this is too much, you don't have to do this part. But so they told us what the variable would be. So now I can actually give the perimeter is 10 millimeters. And we're going to do one more like that. And you can just drag your numbers. Number 15. Okay. How that 5 got up there? All right. So here, let's see. This is a 1, 2, 3, 4, 5-sided polygon. So it's a pentagon, but it's not like we would normally see. They're not all the same size. So it's an irregular pentagon. Regardless, we're going to put all of our, add all of our sides together. So we've got 1, 2, 3, 4, there's 5 x's. Okay, so I've got that. And now all of my constants. So, and again, if you want to use a number line, you could start with your positives first, 3 and 1. So you've got 4, and then you subtract 4. So now you're at 0, and then you subtract 2. So then you're at -2. Okay, or you could say -4 plus 3, and you get to -1, then -2, that would be -3. Then you add 1, and you'll be at -2. Okay, so 5x minus 2. And this one also has the extension, and so it's going to tell us, all right, how about if x is 15 inches, what would the perimeter be in inches? So we substitute 15 in for our variable. 5 times 15, that's multiplicative. And we get 75, subtract last, and we actually have a number here. We can say that if x is 15, the perimeter is 73 inches. Okay. Okay, so you're going to give 16 through 20 a try on your own. And I will send the answers in your Google Classroom by the end of class. Then I want you to try the cool down slide also, yesterday's cool down if you didn't get a chance. And I will take questions about yesterday's if you have any questions. And just try to get your coordinate plane review task in today, if not today, tomorrow, Wednesday, and your spiral review is due Thursday. Okay. All right. I will see you on